Okay, ladies and gentlemen, we're going to go through the Chapter 8 and Chapter 10 review packet. And in an effort not to bore you to tears, I'm going to move as quickly as possible. Once again, pause, work a problem, forward, mute, I don't care. Just get through it so that you can ace this when we see you next time. Okay, so for number 1, if we know that PS is 8 and we know that PR is 4, and we're looking to find PT, which is X over here. So if I think about what I know a short side, a short leg, and a long leg for the medium-sized triangle and the large-sized triangle. So for the medium triangle, that's going to be the short leg is 8 and the long leg is X. And if we do the small triangle, the short leg is 4 and the long leg is 8. In order to solve this, I'm going to cross multiply. 8 times 8 is 64 and 4 times X is 4X. I'm going to divide both sides by 4. X equals 16. So in this particular case, segment PT is 16 units long. Use a special right triangle to write each trigonometric ratio as a fraction. So sine of 60 degrees, you will need to know this. This is 30 degrees, this is 60 degrees, and this is right. We said that if we know that the length of the short leg is x, we know that the hypotenuse is 2x, and the long leg is x times the square root of 3. So I'm going to come over here and remove this to remind myself that the sine is the opposite over the hypotenuse. So sine of 60 degrees is opposite x times the square root of 3 over the hypotenuse, 2x. This is a spot where people got confused. I'm multiplying the top by x and the bottom by x so I can cancel those two things out, which is going to give me the square root of 3 over 2, and I am perfectly fine with that answer. You can go to your calculator. Nope, it says as a fraction, so it doesn't want you to determine what the decimal is. So now I have to figure it out for cosine of 45 degrees. And remember, we can only do this for a right triangle, so I know that this triangle is a 45, 45, 90 triangle. If I know that each of the legs is x, I also know that the hypotenuse is x times the square root of 2. I'm going to remind myself that cosine equals the adjacent over the hypotenuse. So I look at everything in relationship to 45 degrees, and I know then that the cosine of 45 degrees equals x over x times the square root of 2. And in class, we reminded ourselves that we could cancel out these two x's, and then things fell apart. When you cancel that x on the top, you still have 1 on the top, and what you've got left is the square root of 2. And that is a perfectly fine answer. Moving right along, use your calculator to find each trigonometric ratio round to the nearest hundredth. So I'm going to come over to my calculator, I'm going to hit tangent, enter, and I need to know about 84 degrees, and it says 9.514. So 9.51. 4 is not big enough to round that other number up. So that's what I get for that. We need to find the cosine of 13. So I'm going to hit cosine 13 degrees and hit enter, and that gives me 0.974. Again, 4 is not big enough to round the number in front of it up, so my answer is approximately 9.7. Okay, number 4, find each length round to the nearest tenth. So I'm looking for CB, and everything that I'm going to do, I'm going to think about in terms of angle A, which is 22 degrees. So in terms of A, what I know for CB is I know the adjacent, and I need to know the opposite. And I think about the trigonometric ratios, SOHCAHTOA, and tangent is the one that uses opposite over adjacent. So I'm going to plug in there my opposite. So let's see, tangent of 22 degrees equals, the opposite is x and the adjacent is 15. So x equals 15 tangent of 22 degrees. So I come over to my calculator, I say 15 times, I hit the trig button, I toggle over to tangent, hit 22 and hit enter. My answer is 6.06. So x is approximately 6.06. Oh, this one says round to the nearest tenth. So I need to adjust that. So I'm going to say that CB is approximately 6.1. All right, let's come over here and talk about AC. So now we're going to still think about everything in terms of this angle that's 22 degrees, but I'm looking for, I'll call it Y to minimize confusion. Now I'm looking for the hypotenuse. I still know the adjacent, that doesn't change, but what I need to know is the hypotenuse, and that's ka of SOHCAHTOA, which is cosine equals adjacent over hypotenuse. So let's plug in what we know. Cosine of 22 degrees equals the adjacent, which is 15 over y. Now I'm going to multiply both sides by y, and that's going to allow me to cancel those two y's out. We're always multiplying by the denominator, always the denominator. So we get y times cosine 22 equals 15. I'm trying to get y alone, so now I've got to divide by cosine of 22. Remember, I can go to my calculator and type in cosine of 22, and that's just a regular old number. So y equals 15 cosine 22, and that is equal. At this point in time, we haven't done anything that's caused any rounding, so that's still an exact number. And now I'm going to go to my calculator, and I'm going to type in 15 divided by, trig button, toggle over to cosine, hit enter, and then 22. And that tells me 16.178. They want me to round to the nearest tenths, so y is approximately 16.2. So I'm going to come over here and say that AC is approximately 16.2. Number 7, we need to find sine of B. B is over here. Sine SOHCAHTOA, so opposite over hypotenuse. So that is 24 divided by 25. That is an exact number. I'm going to go to my calculator. I'm going to divide 24 by 25. And I'm going to remember to hit the decimal button and hit enter. And that tells me that the answer is exactly 0.96, and it wants it as a fraction and as a decimal. So there's one answer, and there is the other. Both of those are equal. Now I'm going to look at, whoopsie daisy, I didn't mean to move the whole thing. Now we're going to look at angle A, and we're going to do cosine of angle A. Cosine is adjacent over hypotenuse, which is again 24 over 25, which is still going to be 0.96. All right, and yes, that can happen. How about tangent of A? Tangent is opposite over adjacent. So opposite of angle A is 7. And adjacent, well, 24 and 25. 25 is the hypotenuse, so that's not what we're using. We're going to say over 24. So now I'm going to divide 7 by 24, hit the decimal point, and hit enter. And now I've got this long thing that I need to round, and it says to the nearest hundredth. So I look at the third digit. It is not big enough to make the 9 change. So this is now approximately 0.29. So those are my two answers for that. Now we're going to go to our calculator and find each angle measure to the nearest degree. So I'm going to go hit the trig button and toggle over to cosine inverse. I'm going to hit enter and 0.97, and that tells me 14, and it says round to the nearest degree. 14.06 is going to be 14 degrees. Tangent inverse, so trig function, tangent inverse of 2 gives us 63 degrees. This is approximately 63 degrees. I'm going to come over and do trig function, arrow down to sine inverse of 0.59 and hit enter. That gives me approximately 36 degrees. San Francisco's Lombard Street is known as one of the crookedest streets in the world. The road's 8 switchbacks were built in the 1920s and make the steep hill passable by cars. If the hill has a percent grade of 56, what angle does the hill make with the horizontal line round to the nearest degree? So what that means is for every 100 feet traveled this way, we go up 56 feet. All right, so I am looking for this angle. I'm going to call it angle H. So I think about angle H and I think about what I know. What I need to know is angle H. And what I have is the opposite and the adjacent. Well, tangent uses opposite and adjacent. So I can say the tangent of angle H equals 56 over 100. So this is when I go to my calculator. When I'm looking for an angle, I use the inverse functions. So I go to my calculator and I type in tangent inverse of 56 over 100. Let's come to the calculator. I'm going to hit trig function, toggle over to tangent inverse, hit enter, do 56 divided by 100. And that tells me that that angle is 29 degrees. So the measure of angle H is approximately 29 degrees. Find the angle T, round the angle to the nearest degree. So what I need is angle T, and in relationship to angle T, I know SR, which is the opposite, and I also know the hypotenuse. Well, SO uses that. So sine of angle T equals the opposite, which is 5 over the hypotenuse, which is 5.7. Whenever I'm looking for an angle, I go to my calculator and I use the inverse function. So T is equal to sine inverse of 5 divided by 5.7. Come to my calculator, trig function, toggle down to sine inverse. 5 divided by 5.7 gives me 61 degrees. The measure of angle T is approximately 61 degrees. Find QR, round the length to the nearest hundredth. I need QR, so I've got angle S told to me. In relationship to angle S, QR is the opposite. No, I lie. What I need is the opposite. What I know is the adjacent. And when I think about SOHCAHTOA, I know that tangent is the trig function that uses opposite over adjacent. So I say tangent of 56 degrees equals the opposite over the adjacent. The opposite is what I need to know, and the adjacent is 14 kilometers. From here, I multiply both sides by the denominator. This allows me to cancel out the denominator and get x by itself. So we know that x is 14 times tangent of 56 degrees. Please write the 14 in front to avoid confusion on the calculator. So 14 times trig function tangent. Anytime I'm looking for a side length, I'm using sine, cosine, or tangent. Anytime I'm looking for an angle, I'm using cosine inverse, sine inverse, or tangent inverse. We are looking for a side, so we just use straight tangent. So tangent of 56 degrees, and I hit enter, and it says round to the nearest hundredth. So x is approximately 20.76. So QR is approximately 20.76 kilometers. Number 12, find angle Y. I'm looking for an angle. I know I'm going to use cosine inverse, sine inverse, or tangent inverse. So I look at what I've got. I'm over here. I need Y. In relationship to Y, I know the adjacent and I know the hypotenuse. And the thing that uses adjacent and hypotenuse is cosine. So the cosine of angle Y is the adjacent, which is 31 degrees, over the hypotenuse, which is 36 degrees. So again, if I'm looking for an angle, I use cosine inverse, and I find the cosine inverse of 31 over 36. trig function cosine inverse, 31 divided by 36 gives me 30.558. Y is approximately, oh, we're rounding to the nearest degree, so this is 31 degrees. So the measure of angle Y is 31 degrees. What is EF, the measure of the longest side of the sail on the model, round to the nearest inch? So I've got this triangle, this is 65, this is a right angle, this is 28, and I am looking for EF, which is this length right here. I know 65 degrees, and in relationship to that 65 degrees, I know the opposite, and I need to find out the hypotenuse. And I remember that SOH, S-O-H, stands for sine, equals opposite over hypotenuse. So the sine of 65 degrees equals the opposite, which is 28, over the hypotenuse, which is what we're looking for, so we called it x. We're going to multiply both sides by the denominator to clear that x out of the bottom of that fraction. That cancel these two things out. So 28 equals x times sine of 65. Well, I still need to get x by itself. I'm going to divide both sides by sine of 65. Remember, we go to our calculator, that's just a regular number. So x is equal to 28 divided by sine of 65. So 28 divided by trig function sine of 65. And I'm going to hit enter. That tells me that EF, the hypotenuse, and I'm going to round to the nearest inch, is approximately 31 inches. And that makes sense because it's the hypotenuse and the long side is 28. So it's okay that the hypotenuse is longer, but not by much. Okay. Let's take a look at this one. This says find the shaded region. So we learned about composite areas. So I'm going to use the formulas that I know. I know that the area of the trapezoid is 1/2 the base 1 plus base 2 times the height. So let's do the area of the trapezoid. So I know 1/2 base 1 can be 12, base 2 can be 9.5. The height, well, my diagram shows a radius of 4.5. So that means this right here is 4.5 and this right here is 4.5. So my height is 9. All right. So I am going to come to my calculator and I'm going to say 0.5. And then I'm going to use some parentheses. 12 plus 9.5. I'm going to use the arrow button to get on the other side, and I'm going to multiply by 9 and hit enter. That tells me it's 96.75. 96.75. I'm not going to round that just yet. Okay, just wanted to check that. I need to know the area of that semicircle. If I know the area of a circle is pi r squared, then half of a circle is just going to be 1/2 times pi r squared. So the area of my circle is going to be 1/2 pi times r squared, which is 4.5 squared. So I'm going to come over to my calculator and I'm going to type in 0.5 instead of 1/2. I'm going to multiply that by 4.5 and hit the squared button. And then if you remember, I'm going to use this pi button. I hit that and I'm going to hit enter and enter again. And I find out that the area of my semicircle is, I'm going to round this because it's really long, 31.81. So the area of my trapezoid plus the area of my circle gives me the whole shaded region. So that's 96.75 plus 31.81. So I'm just going to come to my calculator and do 96.75 plus 31.81 and hit enter. So the area of my shaded region is approximately 128 oh, it says nearest tenth. So I'm going to round up 0.56 rounds to 0.6. And that is an area, so I'm going to say centimeters squared. Find the area of the shaded region, round to the nearest tenth. I've got a square where somebody chopped off a corner. The area of this square is going to be 25 times 25, right? So I'm going to say the square equals 25 squared. So let's see, 25 squared gives me 625. And then I have to deal with this rectangle, or excuse me, this triangle right here. So I'm going to take this and bring it down. Well, if this right here is 10 and this right here is 25, that means that the height of my triangle is 15. And if this right here is 5 and this right here is 25, that means that this is 20. So I'm going to come over here and talk about the area of my triangle, which is going to be 1/2 base, which is 20, times the height, which is 15. Half of 20 is 10. 10 times 15 is 150. So the area is going to be the area of my square minus the area of my triangle, which is going to give me 625 minus 150. 625 minus 150 equals 475 square yards, and that is an equal to, we did no rounding for that one, so we're good to go. Find each measure. The area of circle D in terms of pi. The area of a circle is A equals pi r squared. I know that r is 7, so the area in terms of pi is 49 pi, and that's it. Oh, excuse me, 49 pi feet squared. For number 17, we find the circumference of circle T in which the area is 6 pi millimeter squared. So the area of a triangle, or excuse me, of a circle is pi r squared. And if I know that the area is 16 pi, then I can say, well, let's divide both sides by pi. Pi is just a number. I can do this. I can cancel out pi here and here, and that's going to give me that r squared equals 16. Well, we go and we take the square root of both sides. The square root of r squared is r. The square root of 16 is plus or minus 4. When we're talking about distances, we're always going to choose the positive. We are not finished. The question asks for the circumference of circle T. So the circumference of a triangle is 2 pi r. So we've got to take this number and plug it in here. The circumference is going to be 2 times pi times 4, which means that my circumference is 8 pi. I'm not finished. I need to think about the measurements. Remember, area is millimeters squared. It's an aerial measurement. We need to figure out the linear measurement. So this is going to be 8 pi millimeters, but not squared. All right, last one. Chris is shopping for a new bicycle. He sees that a trick bike has a 20-inch diameter, a mountain bike has a 26-inch diameter, and the racing bike has 27-inch diameter wheels. Find the area of each wheel, round to the nearest tenth. So the area of a triangle, or I'm so sorry, the area of a circle is pi r squared. Well, I know my diameter. My diameter is 20, which means my radius is half of that, which is 10. I know my diameter is 26, which means my radius is half of that, which is 13. I know my diameter for this one is 27, which means half of that is the radius at 13.5. So I'm going to continue to use that for my area. So my area is pi times 10 squared. 10 squared is 100. So this is 100 pi. We're not finished. We need to plug pi in, and I'm going to do that all at once. The area for this one is pi times 13 squared. 13 squared is 169 pi. The area for this one is pi times 13.5 squared. And I'll be honest, I don't know what 13.5 is. So I'm going to come over here and plug that in. That gives us 182.25, 182.25 pi. All right, since I'm over here, I'm going to go ahead and multiply my answer by pi. And I'm going to round it to the nearest tenth. The nearest tenth is 572.6. 572.6, and this is square inches. All right, we can move on to 169 pi. So 169 times pi, rounded to the nearest tenth, is 530.9 square inches. And then 100 times pi gives us 314.2 inches squared. I got to write really tiny for this. And the question goes on to ask, if he wants a bike that has wheels with a radius of less than 14 inches, which bike should he buy? We've got a radius of less than 14 inches, we've got a radius of less than 14 inches, and we've got a radius of less than 14 inches. He should buy whatever makes him happy. Well, that's it. If you have any questions, come see Mr. Lozar or I before school or during Lion Time. And if you have any other issues over the weekend, feel free to shoot us an email and we will get back to you as soon as we can. Have a great weekend and a happy Monday off. I know I will enjoy that time off. Thanks. Bye.